We'll proceed in vector algebra and calculus. Vector algebra and calculus. So vector is considered as the most advanced idea in in a mathematics because vector provides a separate capability to any part in mathematics, that is direction. Otherwise, direction is not available neither in numerical science nor in algebra. Algebra is variable to the numerical mathematics, where it may vary with the variable like x, y, z. This can be in the Cartesian coordinate system, or it can be polar, cylindrical, or a spherical coordinate system. Now, using the vector, we are in a mood to calculate the surface area of a 3D shape. And in that shape, surface area of the 3D shape, now we want to calculate surface area of a right angle cone. Okay, so this is a big paper and this is the right angle cone. This is right angle cone. Now, if this is a right angle cone, or I can make it smaller. Okay, so this is a right angle cone. Okay, right angle cone means if I keep it on xy plane, this is xy plane and blue color is the center. Now, if I keep it on xy plane, this is really a right angle cone. If I keep this on xy plane, then if this is a circle and circle center is matching the actual origin, then if I connect a line, if okay, then if I connect a vertical line from here, that is z axis, this is x axis, this is y axis, this is z axis. Now, if I keep this cone here, then it forms a circle on xy plane. If it forms a circle on xy plane, then this origin and center of the circle are coinciding. In that case, if I draw a vertical line and this vertical line is meeting this apex, then it is called right angle triangle. What is the surface area of right angle triangle? Okay, now to calculate the surface area of right angle triangle, I am going to tilt it. Surface area is same, right? Either you make like this or you make like this. What is surface area of this cone? So this is a cone and this surface area. I'm not talking about this. Only this surface area. This is simple, right? If this radius is a, then this surface area is pi r square. What about this slant surface area? That is matter of interest out here. If that is the case, if I keep like this, then cone formula can be complex. But I am going to take a formula of a cone where x square plus y square plus z square, okay, I mean z equal to square root of x square plus y square. That is one possible formula of a cone. Z means height. Formula of a cone means fxy is what? Z is what? Against the independent component x and y. Since x and y are independent component and z is dependent component, z is the height, that is function over x and y. F x comma y equal to what? That is the equation of a 3D. So equation of 2D is fx equal to what? That is y. Y equal to what? 3D is fxy equal to what? Z equal to what? Z equal to square root of x square plus y square. It is one of the formula of a cone. Cone formula may differ. How it differ? It depends upon the top angle. From here, if I draw a straight line, this is a circle. From the center of the circle that comes in the middle. From there, I draw a vertical line till this apex or apex, and this is a slant line. It forms an angle. Or if I just cut it here, if this is x-axis, this is z-axis, if I cut in xz plane, then from top, then there will be a triangular it will cut. Makes sense, right? So if this is a cone and if I cut in XZ plane, then it makes a triangle shape. That top angle, depending upon the top angle, now it matters. Depending upon the top angle, then formula equation of this cone matters. If top angle is 90 degree, if top angle is 90 degree, then what in that special case, what would be the scenario? If that is the case, if top angle is 90 degree, okay, top angle is top angle is 90 degree. If that is the case, then half of the top angle it forms a triangle, right? If I cut triangle at the middle, then half the angle would be 45 degree. This is anyway 90 degree. This is 45 degree. If that is the case, then height and width is same. Makes sense, right? If I have a cone, if I have a cone, up. If I have a cone and this is kept on a xy plane and this is a circle, then circle, if I cut in like this, then it forms a triangle. Top angle is 90 degree. If that is the case, if this is the triangle, at the center I draw a line that is the height of the cone, then this angle is 45 degree. And anyway, at horizontal from the center of the circle, it makes a line that is the radius of this circle till this end. So this forms a triangle. This is 90 degree, this is 45 degree, this is 45 degree. If that is the case, then height and radius are same, a special case. Okay, still I consider this as height, that is h, and radius is a, and slant line is L. Okay, now the equation of the cone would be the height, that is z, at any moment is square root of x square plus y square. Because at any moment, if I see this circle, if I see this circle, this is x-axis, this is y-axis. If I take this way, then on any point inside the circle, if this cone is kept like this, then any point inside the circle, any point inside the circle, if this is x comma y, if this is x comma y, then x square plus y square root at that moment is the radius. Understandable, right? If I take any circle, if I take any circle here, and x comma y is on the circumference of the circle, consider, then x square plus y square root is the radius of the instantaneous circle. If x is full kind of x, if I take that is a on the x-axis, then y is 0. A is the radius of the full-fledged cone circle. Then radius is x only anyway. But at any point, if I take, then if I take at any point along the inside the if, oops, okay, so consider that consider that this is the circle. The circle is very small. Okay, small is all right. If consider this is the circle of the cone. Consider this is the circle of the cone is kept like this. This is the circle of the cone. Okay, if this is the circle of the cone, I take any inside it. I take any point x comma y. Okay, inside the circle, I take any point x comma y. If I take any point x comma y, then at that moment x square plus y square root is the hypotenuse at that point. Now, if I take that height, whatever x square plus y square root is, then that if I take height, then it will form a small cone, something like that. Okay, or the height at that moment, I'm messing up something. Okay, so consider the kind of equation of the cone is z equal to a square root of x square plus y square. Just consider z equal to a square root of x square plus y square. This someone would have studied in the book. Okay, what would be the scenario for the x square plus y square being the z. If that is the scenario, then first of all we are talking about tilted cone. Tilted cone. Now the cone is like this because when x is 0, y is 0 at the origin, height is 0. When x, y, when kind of x and x is 0, y is 0, then height is 0. If I keep like this, when x is 0, oops, if I keep like this, if I keep like this, when at x comma y is 0 0, then height is going till the apex. Okay, but I don't want that. If I say z equal to square root of x square plus y square, then this is tilted cone, upside down. Now when x equal to 0, y equal to 0, at that point this height is touching here. But as we go along x and y, this height is growing. Here height is this much. If I go more in x, then height is bigger. If I go more in x, height is bigger. Now consider that whatever, if I say x square plus y square square root, wherever x and y point I am taking a square root means that point is the length from the origin. If I take any point x comma y, then x comma y on the xy plane, then x square plus y square square root is the distance from the origin. Consider that this height is at same distance. Consider this height is at same distance. This is what we are talking for the right angle triangle. So height is at same distance. Possible, right? This cone is like this. This cone can be like this. This cone can be sharp also, very sharp also. Okay, so everywhere in this sense height is different. If a cone is very flat this way, then height is less at same x comma y. If cone is sharp like this, then at same x and comma y height is more. So height depends upon this angle when it is making. This is what we are saying. Now if I take it as 90 degree or from vertical 45 degree, then in that sense this length and this length would be same because this angle is 45 degree. This is anyway 90 degree. Actually story is like this, but I tilted it. Now in this fashion, this height at that point, this height is same as x square plus y square square root. Now I can say z equal to, in special case, at a particular angle case, but that is also a cone only, right? So in that special case, z equal to square root of x square plus y square. Now what is the surface area, slanted surface area of a cone that is under question mark? This is what we want to calculate. Z equal to square root of x square plus y square. Now if that is the case, then how we can calculate? Now I'll take one point here, the way we now will do in cylindrical coordinate system, and we will do in three ways. We will do in three ways. One way is through the dp by dx cross dp by dy magnitude integrate with the xy plane. One way. Second way is the cylindrical coordinate system. dp by d theta cross dp by dr magnitude d theta dr. Third way, the p dp by d theta p will not be xi yj zk. It will be in form of theta r and z. What is cylindrical coordinate? Please watch previous video. What is cylindrical coordinate system? If I see cylindrical coordinate system, if I see cylindrical coordinate system, then I have a circle which has a radius a and theta angle that is 2 pi, and then there is a height h, radius a and angle theta to 0 to 2 pi. This is called cylinder and cylindrical coordinate system, theta, r and z. These are, so we are trying to find the surface area of a cone through cylindrical coordinate system. First let's see the what it is. Now if I take any point P on this cone, any point P on the cone, this is origin. If I connect through a line, that is called position vector. If this point is x comma y comma z, then position vector is xi plus yj plus zk. Then velocity vector Along x-axis is dp by dx. Along y-axis is dp by dy. If I calculate dp by dx, position vector is xi plus yj plus zk, dp by dx, that is called velocity vector. dp by dx is I plus dz by dxk. dp by dy is j plus dz by dyk. If I do cross product of dp by dx cross dp by dy, dp by dx cross dp by dy, then at any point dp by dx is I plus dz by dxk. That is x z plane. If this is x axis, this is y axis, this is z axis. This is xz plane. If this is xz plane, then dp by dx, that is I plus dz by dxk, it falls in dp by dx is a vector. If p is a vector, xi plus yj plus zk, that is a position vector connecting from origin to any point p, then dp by dx is I plus dz by dxk, that is a vector. That vector hangs in xz plane. dp by dy hangs in yz plane. If the, if that is the case, then dp at any point p, dp by dx is this vector. Anything in xy plane, xz plane, dp by dy is this vector. Anything in yz plane, okay, this is yz plane. J plus dz by dyk, okay, that is dp by dy. dp by dx is I plus dz by dxk, where p is xi plus yj plus zk. Partial derivative we have taken. If I do cross product dp by dx cross dp by dy, if I do cross product of dp by dx cross dp by dy, at that point it will give me the surface area. That is called velocity surface area vector. Velocity surface area vector. dp by dx cross dp by dy. dp by dx is velocity vector. dp by dy is velocity vector. If I do cross product, then it gives me velocity surface area vector. Velocity surface area vector, because cross product of two vectors would give the surface area. But this is velocity surface area. We have done it in the past video. Now if I calculate magnitude of this dp by dx cross dp by dy, dp by dx cross dp by dy, this vector is called velocity surface vector. Velocity surface vector. Now in this velocity surface vector, if I calculate the magnitude of velocity surface vector, it gives me the velocity surface. Integrate with the xy plane will give the net surface area. Integration of velocity gives the displacement. If I have velocity surface vector, integration of this would give the displacement, that is the surface area. dp by dx cross dp by dy, magnitude dxy plane. Okay, if that is the case, let's calculate the dp by dx cross dp by dy magnitude and integrating it with dxy plane, and then x and y, limit is x and y. What is limit in x and y? That limit is that where it is going. It is going maximum this to this circle, or if I make it opposite, then x and y is the circle that it is falling on the xy plane. If I see this cone is making on the xy plane a circle, then that limit is that circle. X and y must be confined in the circle, including the boundary. That is the integration. So integration in the circular region in xy plane, and then dp by dx, dp by dy cross magnitude dxy plane would be the kind of surface area of the cone. Okay, what is dp by dx? What is dp by dx? That is that is I plus dz by dxk. What is dp by dy? J plus dz by dyk. If I do cross product, then it will come as minus dz by dxi minus dz by dyj plus k. If I calculate the magnitude, then dz by dx whole square plus dz by dy whole square plus 1 and then square root. dz by dx whole square plus dz by dy whole square plus 1 square root. So That is the magnitude. Now that I have to integrate with the xy plane, and limit is the circular region on the xy plane. That is the circle. That is the circle. This cone is forming on the xy plane. That is the region. So that would be the surface area. Let's do it. Dz by dx whole square. What is z? That is under question mark. Now what is if this is the cone, this is the height of the cone. If this is the height of the cone, then this is the cone. Okay, consider this is the cone. Consider this is the cone. If I cut from top, the cone is kept like this on the xy plane. This is the cone. If this is the cone, then this is the height of the cone. This is the height of the cone, h. H is the height of the cone and radius is A. A. This is the slant line, that is L. L is nothing but A square plus H square root. Okay, if that is the scenario, then what is the relationship at any moment? At any moment, if this is A, at any moment, if I take any point x comma y, then let's consider I cut it here. Understandable, right? This is a cone, top cut of the cone. This is the height at the center. This is the height h of the cone. H square plus radius of the cone a square equal to slant line, that is L. L square equal to h square plus a square. Now let's cut the cone at any height z. At any height, I have tilted the cone. Let's cut the cone at any height z. At any height z, if I cut it, then it forms another circle here. That radius is r. Okay, that radius is r. If that is the case, if radius is r, then this h by a, this h by a is same as that moment z by r. Make sense? Or if someone is happy with the actual cone we have taken like this, in that form, this is the height of the cone. If I cut it any place z here, it forms a circle. Okay, this circle radius is a, that is the circle radius of the cone. If I cut it at the height z, it forms another circle here, that radius is r. Radius is r. If that is the case, then h, the full height, h by a is same as z by r, because angle is same. Makes sense? So h by z, h by a equal to z by r. So z equal to h by a into r. Z equal to h by a into r. This r is nothing but x square plus y square root. So z equal to h by a. Z equal to h by a square root of x square plus y square. Let's try now. Dz by dx, this is our proof. It may not, I have not checked, but it may not be available in any of the book. Please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. Now, if that is the scenario, then z equal to h by a into square root of x square plus y square. Let's put it here. The surface area of this cone is dz by dx whole square plus dz by dy whole square plus 1 square root dx dy, and limit is in a circular region of the cone. Circular region of the cone that is kept on xy axis. Or if it is like this, then whatever it is. Same thing. Now, what is dz by dx? Z equal to h by a square root of x square plus y square. Dz by dx would be now h by a x by square root of x square plus y square. If I go with the chain rule, dz by dy h by a into y by a square root of x square plus y square. Let's put there dz by dx whole square plus dz by dy whole square plus 1. then it becomes h square by a square x square by x square plus y square plus h square by a square y square x square plus y square plus 1. If that is the case, the numerator will become h x square plus y square plus bottom a x square plus y square will go at the end. It becomes h square plus a square in bracket, another bracket x square plus y square. Denominator is a square and x square plus y square. X square plus y square will go. Now it is h square plus a square by a square root dx dy. All are constant only. Now h square plus a square is the slant line of the cone, that is L square. It comes at L by A. Okay, L by A I can keep outside because it is a constant. L by A integration over a circular region dx dy. dx dy. L by A. Okay, dx dy. Okay, how I can go ahead with this? Okay, now kind of it is, if someone consider this, I believe it is same as it is this this would be same. Okay, what is now if x, okay, what is x? X is minus a to a. What is x? Is minus a to a. I believe I am not missing any point. X is minus a to a. What is y? Minus the square root of a square minus x square to the square root of a square minus x square. This is a circle. If this is a circle, if I transform into polar coordinate system, then theta will be 0 to 2 pi and radius will be 0 to a and Jacobian will be r d theta dr. That will be r square by 2 and a square by 2, a square by 2, 2 pi, 2 gone pi a square, a gone. Then it will be pi a l. Anyway, let's not take the shortcut. Anyway, x is minus a to a. If I have a circle, if the cone has a circle at the base and x is minus a to a and y is minus a square root of a square minus x square to plus a square root of a square minus x square. If that is the case, then let's integrate y first. Then integration of y is y, dy is y, minus square root of ax square minus x square to square root of a square minus x square. Okay, so that would be, I believe, 2 square root of a square minus x square. 2 square root of a square minus x square. 2 I can keep outside. Now it becomes 2l by a. Now integration of a square root of a square minus x square dx. What is a square minus x square dx? Let's consider x equal to a cos theta. Then it will become a sine theta. The square root of a square minus x square will become a sine theta. Now x equal to a cos theta, that would become a minus sine theta d theta. If that is the case, then it becomes a square. A square now outside we have kept l by a. L by a square, it becomes l into a. Sine square theta, negative I am not taking. Sine square theta d theta. That integration is theta by 2 minus sine 2 theta by 4. Sine square theta integration is. Okay, if that is the case, then theta by 2 minus sine 2 theta by 4. Now x is minus a to a. I had taken x equal to a cos theta. Theta equal to x by a cos inverse. If x is minus a, cos inverse minus 1, that is pi, and then cos inverse 1, 0, pi to 0, pi to 0, pi to 0. Now the integration is theta by 2 minus sine 2 theta by 4. So that will result in pi by 2. Okay, that would result in pi by 2. This is what I believe so. Okay, whatever I have kept outside. We have kept outside. It will result in, I believe, one sec. Okay, I'll try again. It is really difficult. Okay, a square, the outside we have pi into a. Outside we have pi in, sorry, L into a. Outside we have L into a. And inside we have sine square theta d theta. That is theta by 2 minus sine 2 theta by 4. Now theta, if I see x, that is minus a to a. If that is the case, minus a to a, then it resolves in kind of pi pi to 0. Pi to 0 means pi by 2. Pi by 2 is the integration. What I have kept outside, I believe 2 I am missing, because 2 also I had kept outside. 2LA. I'll try with the beginning again. So we are trying to calculate integration where x is minus a to a, y is minus a square root of a square minus x square to plus a square root of minus a square minus x square. That is a circular region of radius a. dy dx. dy integration is y minus a square root of a square minus x square to square root of a square minus x square will go to a square root a square minus x square. Outside I have L by a. Now it becomes 2L by a. Square root of a square minus x square. Let dx, a is minus a to a. If x is a cos theta, then it transforms into a sin theta. And dx will transform into a minus sin theta d theta. A square will go outside. It becomes now L into a into 2. 2LA. Now inside we have d theta. We have sine square theta d theta. Integration is sine square theta d theta, integration is theta by 2 minus sine 2 theta by 4. Okay. Now theta is my x in minus a to a. Theta will become pi to 0 as per x equal to a cos theta. Pi to 0 means theta equal to cos inverse x by a. When x is minus a, cos inverse minus 1, that is pi. When x is a, cos inverse 1, that is 1, 0. Pi to 0, and then theta by 2 minus sine 2 theta by 4. Sine 2 theta is gone. If it is pi and 0, theta by, it is pi by 2. Pi by 2 into pi L into LA2. 2 gone. Pi LA. So if there is a cone, if there is a cone, if there is a if there is a cone, if this is a slant length L and this is the radius A, then it is pi AL is the surface area of this cone. I'm not talking about this base surface area, only this cone slant surface area, that is dP by dx cross dP by dy magnitude dx dy integration over this circular region. Okay, that is pi L into A. What about if I try full play, if I try in a cylindrical coordinate system? If I see cylindrical coordinate system, then x equal to r cos theta. We have two triangles, right? Okay, if this is the cone, if this is the cone or this is the cone, tilted cone, this is what example we are taking. One triangle, two circle, right? One circle is this base circle, that radius is a. One circle at height z, I cut another circle, that radius is r. At any circle r, at any moment, let's consider the point on the xy plane. At any moment, x and y is the x square plus y square equal to r square. R square. That is the at height z, r square. So x equal to r cos theta, y equal to r sin theta, x equal to r cos theta, y equal to r sin theta, and z equal to z. Z equal to z. That is cylindrical coordinate system. If that is the case, now we have dP by dx cross dP by dy magnitude dx dy, that is the surface area. That is equivalent to d surface area by dxy plane. D surface area, I have demonstrated it many times. D surface area by dxy plane into dxy plane. into, let's consider what is variable here. If I'm calculating the surface area of a cone considering a cylindrical coordinate system, what is variable here? All three are variable. The radius here, at any moment, if I see any point here, then radius is changing. Here, at this moment, radius is full A. Otherwise, every moment, radius is changing. Every moment, Z is height is changing. And every this circular region, theta is changing. All three are changing. Okay, let's take any two. Let's take theta and r, not z. Or let's take z, not r, whatever comes to mind. Let's take theta and z. Let's take theta and z as variable. If that is the case, then we have surface area as d surface area by dxy plane, that is velocity vector, into dxy plane. Now let's multiply with d theta r by d theta r. xy plane went. Now it is d surface area by d theta r into d theta r. That is, the surface area by dxy plane was dp by dx cross dp by dy. Now it is dp by d theta cross dp by dr, magnitude d theta dr. If that is the case, then p is r cos theta I plus r sin theta j plus zk. And again, so this by d theta cross d by dr, dp by d theta cross dp by dr, magnitude. What is d theta? Now what is z? We have calculated that h by a equal to z by r. Z equal to r into h by a. So I can say r cos theta I, p vector is r cos theta I plus r sin theta j plus h by a r k vector by d theta cross same by dr. By d theta, then it becomes r minus sin theta I plus r cos theta j plus nothing. That side, if I do by dr, then it becomes cos theta I plus sin theta j plus h by a k. Now calculate this cross product and the magnitude. We will do it. So I am not running away. So the first is r minus sin theta I. There I term is gone. We are not taking care. J term is sin theta. So minus r sin theta, there sin theta, r sin square theta, k, r sin square theta, k. Now, okay, and then next is I cross k, I cross k. Let's leave it. Now, next term is j term, the first one. J term is r cos theta. So r cos theta, and there I term is cos theta, r cos square theta, k. So one k component is r sin square theta, one k component is r cos square theta. If I add, it become r only. So settle it. Rk, Rk. Now third component, now go with the third component multiplication. First dp by d theta. First is a sin theta I. A sin theta I with the h by a. Sorry, r sin theta into h by a. That will become r sin theta into h by a. Similarly, this j component will go and multiply there. So I and k, it will form j component. J and k will form I component. Here it is r cos theta. R cos theta into h by a. R into h by a cos theta. So now we have rk, and other two I and j are r. One is r cos theta, one is r cos theta h by a, one is r sin theta h by a. Now if I calculate magnitude of this, then ith component square, jth component square, kth component square root. That is the scenario. So kth component is r square, ith component or jth component will be h square by a square r square cos square theta. One is h square by a square r square sin square theta. If I add, it becomes h square by a square r square plus last one is r square. R I can keep outside. Now it becomes square root of h square by a square plus a square. Make sense? H square by a square plus 1 that resolves into square root of h square plus a square by a, that is L by a. Same thing, L by a. L by a I can keep outside. Now integration is over a circle and r will go inside. R d theta, r d theta, that will resolve in r square by 2. R is 0 to a square by 2, and theta will be 0 to 2 pi, 2 pi, 2, 2 gone. And outside I had kept L by a into a square into theta, that is LA into pi. LA pi is the surface area of a cone as far as the cylindrical coordinate system. Can I go with the pure cylindrical coordinate system? That is another question. Pure cylindrical coordinate system. If I go with the pure cylindrical coordinate system, we did P equal to xi plus yj plus zk. Then x transform into r cos theta, y into r sin theta, and z into z. Or this can be an assignment to try with the z. We tried with the theta r as variable. Someone can try theta z as variable because all three are variable. So it will be dp by d theta cross dp by dz. Someone can try that fashion also. In that case, it will be the r, we have taken r cos theta. R has to be transformed. So r will be replaced by z only. Then it will be, r will be z into a by h. Someone has to replace like that because h by a equal to z by r. Now we proceed and pure cylindrical coordinate system, not p equal to xi plus yj plus zk. Pure cylindrical coordinate system means all three orthogonal will be in theta, r and z, not I, j and k. We did xi plus yj plus zk and then x I transformed, y I transformed, z I transformed, not I, j, k, theta, r and z. This is the concept pure cylindrical coordinate system. Then what is theta component? If I take this circle here, if that circle is this, then theta component is represented by the arc. This is many times we have talked. Arc is the theta component. If this is the theta angle, then the angle this span the arc, that vector is the theta vector. That length is considered as, this is radius a theta. So one vector is a theta, another vector is r vector. So r theta vector. One is radius vector, that is r vector, and one is z vector, that is z vector. This is pure. These are not available in any of the book. Now let's try dp by d theta cross dp by dr, the way we did. Okay. Now the theta. Now it is r theta vector plus r vector plus z vector. If that is the case, by d theta cross same by dr. If I go with that, then it becomes, if I do with d theta, then it becomes r theta vector, and all are gone because theta is not there. And this side, if I differentiate with the r, then it becomes theta vector, theta vector plus r vector, r is gone, r vector plus zk, z equal to h by a into r. So h by a, k. Now if I do cross product, then I gone, I and j. So I here is r theta vector, and j means theta and r vector, and r vector is 1. Okay, so it becomes r, just r, and then next cross, here it is r, and there it is h by a. It becomes r into h by a. Now magnitude will be r square plus h by a whole square r square. R I can take outside. Square root of 1 plus h square by a square. Same story again. And then it will be h by a. I can keep outside. Integration of r dr d theta, and same story. Someone can try with the z also. This approach is pure cylindrical coordinate system where three orthogonal components we have taken as theta, r and z, not I, j and k. That was partial or hybrid model of cylindrical coordinate. Pure model of cylindrical coordinate system which we can also take, where z is z vector, r is r vector, but theta is represented by the r theta vector. So dp by d theta cross dp by dr, that is r theta vector plus r vector plus z vector by d theta cross r theta vector plus r vector plus z vector by dr. Okay, someone does it, it settles down is in r theta vector, just that's it. And the other side, it settled down is theta vector plus r vector plus z. I can replace with the h by a r, h by a z vector. If I do cross product, then it comes as r, it comes cross product, it comes as r and theta and r vector, means z vector. So r z vector plus theta and z vector. So r vector, r z vector and a h by a r r r vector. If I calculate magnitude r square plus h by a whole square r square root, then r I can keep outside, square root of 1 plus h square by a square. That will be L by A. L by I can keep outside, integration over circular region where r is 0 to a, theta is 0 to 2 pi, and then it will be r dr d theta. It will resolve in pi a L. Same. So three-way we calculated the slant surface area of a cone where we had taken height z equal to square root of x square plus y square. Mind blowing, thrilling. Anyway, please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. Thrilling, mind blowing.